Please welcome Milian.
Thank you, Cornelius, and welcome everyone. It's a pleasure to be here this year on stage in the web track. Last year I chaired this session like Cornelius is doing this year. And during that time, multiple members of the audience asked the presenters like Pierre or Alan from Web Engine and WebKit fame, how is it possible to connect some objects from the C++ world or QtQuick2 world with the HTML clients and the JavaScript clients running inside the web view? Last year I always said, like, it's already possible, just use the QtWebChannel, it's on Qt Labs, whatever, and you need to follow some steps to get it running. Now, 1 year later, it's ready for prime time. It's becoming an official new module with Qt 5.4. And in this talk, I will show you how to use it, what it is about, and why it's required in the first place. And some nice things that followed, which I think none of us actually expected in the first place. So, first, I'll dig a bit into the history, the motivation, what problem do we actually want to solve, and why can't we use the existing QtWebKit bridge. Then I'll present you the details and some technicalities about the QtWebChannel, and do a few demos, actually showing how it works and what you can do with it right now. And then top it off with a bit of an outlook at the end. So, what do we want to do? We have an application which consists basically of three parts, right? We have C++ backend, which encodes the whole business logic, at least that's how it should be. Then you have some kind of UI. Here I said it's a QtQuick GUI. It could be widgets as well, it doesn't matter. Some kind of GUI, so the Chrome, for example, in a app framework where you can select different applications, and then the individual applications could be QML, or maybe that you want to have HTML5 apps running there as well. So you need to have some embedded kind of HTML support. With WebKit or Web Engine, that's very easy to do, but what's kind of hard is the lower part here at the bottom, the bidirectional communication channel between C++ and HTML, or between the QML GUI and HTML. In the last talk, we saw there are WebSockets, which is doable, but it's very mundane monkey coding you have to do. What you want to do is you want your C++ objects or QML objects to be usable inside the JavaScript and HTML the same way you want to, or you write code in the QML JavaScript blocks, right? That's the goal we want to achieve here. With QtWebKit 1, in a historical sense, that was very trivial, more or less, to achieve, because everything lived in the same process. The C++ logic and QML, of course, live in the same process, but also the HTML client lived in the same process. That makes it more or less trivial to share memory between the different parts, and the WebKit 1 code base was completely in hand from us in the sense of Qt, so we could add all kinds of code there, which made it possible to publish objects from Qt or QtQuick 1 in that time to JavaScript. This is called the QtWebKit bridge, and it's been around for years, but it only supports QtQuick 1 and WebKit 1. How did you do it back then? You, in a C++ context, would access the web frame, and then you could publish as many objects as you want to your window object. It's done with the API shown here. You specify some identifier under which the object will be known to JavaScript, and these objects then must be QObjects on the C++ side, and all properties or signals, all methods that are invocable, all these things will be then accessible to the JavaScript clients as well. In QtQuick 1, it was also possible to achieve the same. So you have a web view here. You can set the JavaScript window objects property, publish as many objects as you want. But this time you need to set the identifier actually inside your object. So that's done via the attached property webview.windowObjectName. And again, if you have properties, functions, signals inside your object, these will then be accessible in HTML clients. In these clients then, how do you access them? It's more or less how you would write the code in a JavaScript block in QML, right? So if there's a signal in your object, you can connect the functor to it. You can set properties, read properties, and you can invoke a method and get the return value immediately, because the QtWebKit bridge, since it lives in the same process, could support the synchronous API. That's important for later to remember. Also, these properties and everything are shared memory-wise, so you never actually duplicate the contents of these properties in HTML or in C++. They all access the same memory. So the QtWebKit bridge, in a nutshell, is extremely easy to use. It's highly efficient due to the memory sharing, and it supports a synchronous API, which is often much easier to use for many people. But this last bit, the synchronous API, is actually what essentially killed it once WebKit 2 was introduced, because WebKit 2 introduced the multi-process architecture. Other browsers also do that. Chromium, for example. You have a separate process where the HTML and JavaScript runs, and then somewhere else you have your Chrome, your C++ and QML and whatever. With WebKit 2, then you could not support any synchronous API to talk between HTML clients and JavaScript, QML on the other side, because there was IPC, inter-process communication in between. If you would do that synchronously, you would block every time you try to wait for the return value, for example. And that would be a very, very bad idea. And that also means the WebKit bridge was never supported in Qt 2, because Qt 2 only has support for WebKit 2. So, as I said, in WebKit 2 and beyond, and here I mean Web Engine, for example, or the very thin wrappers around native web views on iOS or Android, we have more or less this structure. We have our Qt application, maybe with a C++ backend, or maybe just QML, maybe the other way around, maybe it's just C++ and no QML at all, and you want to talk to your embedded HTML client somehow. How do you do that? There might be different processes, or in the case of the native web views, we don't even have access to the code to change, for example, Android's implementation of the browser, so we cannot add any extensions there. It turned out that the QtWebChannel, the idea behind it, made all of that work. Noam Rosenthal did a proof of concept for that in October 2011, I think. He was working for Nokia on QtWebKit at that time, and his idea was to add some code to the C++ or QML side, which takes a QObject, introspects the meta object data, and then sends that over the wire somehow. He initially picked WebSockets, and then on the HTML client side, he used the data he sent to reconstruct JavaScript objects. So on the HTML side, you included a library, and then more or less it worked. So let's go through that in some more detail. The Qt meta object, for those of you who don't know, is the heart essentially of any Qt object. It gives us access to methods, properties, and signals which are accessible to QML. It's the whole introspection mechanism that Qt has, and makes it possible to do very, very fancy things. If you've been at the KDAB booth, Gamma Ray relies also heavily on that, and the QtWebChannel is another example of what you can do by leveraging the information in the Qt meta object. So we take that, we serialize that, send it over to the HTML client via some sort of IPC. I mentioned earlier WebSocket works. I'll show later that there are also more efficient ways to achieve that. And then we use that data and construct a dynamic JavaScript object. We add the properties we know it has, we add the signals it has, we add the functions and methods it has, and whenever it's get called or a property gets set, we then transmit it back over the IPC channel to the C++ side and vice versa. So assume some hardware event triggers and you read that on your C++ code and emit a signal. It will transparently be transmitted to the HTML client, who then gets its slot or functor connected to any signal called, and you can act upon it as you would do in procedural JavaScript code in QML. With that said, I want to show you a demo. It's very simple, but I think it should show that it works. This is a pure QML Qt Quick 2 application. And where's my mouse? There. So what you see here on the left side is QML with Qt Quick controls, and on the right side it's an embedded web view with the HTML client running there. Very, very simple. On the QML side, I created a Qt object with some kind of chat API. So it's essentially a signal which gets emitted when a new message comes in, and a method that you can call from your client to actually tell the server that, hey, here's my new message, right? So the JavaScript code for that is extremely simple. Oops. Some setup things, but in the end, you call just a method on your object to do something. And this is actually the message that was received already, that the client connected, and now we can chat. So let's do that. And from the other way around, I can do the same. So that's trivial to do. And of course, the example is, well, very limited. But we actually developed, or we took the proof of concept by Noam and made it work for a production tool, a software piece by a customer of ours. And they rely on that very, very heavily already and make use of that in production. It runs on thousands of or it will run on thousands of embedded hardware devices, and they use it for the HTML app framework thingy. And yeah, it works. So from the setup point of view, I mentioned that you have some piece of code on your C++ and QML side and some more glue code on the JavaScript side. That's the QWebChannel.js file, which you need to include there. And on the other side, you construct your QWebChannel, set up a means of communication between the two, and then you can just register objects and start using it. So from C++, it more or less looks like this. You construct your channel, you register any object you want, and then you can connect to some client. This client I will get to later is essentially the transport mechanism. So, for example, some WebSocket or, as you will see later, the native IPC channel that WEBKIT or Web Engine is using. You can connect to multiple clients. That works as well, so you can multiplex data and yeah. In Qt 2, the thing essentially looks like this. You need to import a few things, and I added a very trivial to use API to WebKit so you don't have to manually construct a web channel just to publish some objects. Instead, you can use the existing experimental.webchannel and register the objects there. Similar to the Qt 1 WebKit bridge, you need to set the identifier under which you want your object to be known to the JavaScript clients via an attached property. In this case, it's called WEBCHANNEL.id. And again, all properties, signals, methods will be serialized, sent over, and then you can start using them from JavaScript. On the JavaScript side, it's not that easy yet to use as in the old QtWebKit bridge times, because you need so far still to manually do some coding. In this case, you need to include the QWebChannel.js library, and you need to construct your web channel. It's in this case a JavaScript object, and again, you give it a transport mechanism. In this case, for efficiency reasons, you can use the navigator.QtWebChannel transport. This will work in any WebKit client running, and it's extremely efficient, much better than WebSocket usage for that, and it will only talk to the QML web view on the other side, so it's also more secure in that sense. And then some callback gets run when the web channel is initialized, and from that point on you can then access your objects. They are stored initially under their identifier you set in the attached property in channel.objects, and from here on it's more or less what you saw before. You can connect to signals, you can set properties, read them. That's easy, but there's a big difference. I said before that synchronous API is not possible because of the multi-process architecture. And if you think about WebSockets, it might even be a different machine altogether, right? So there is no synchronous API whatsoever. Everything is asynchronous. The properties, when you set something, will transparently emit a signal and make sure that the other clients will get notified about that as well. But they have a cache, so you can actually read them in a sense synchronously. But if you want to have the return value of a method, you need to wait for that by passing in a callback at the end after the arguments you pass to your method. And then once this callback gets called, you actually can read the return value as the single argument passed to this function. So it's a bit more work to get it done. I have plans to at least improve the script include and the manual setup of the QWeb channel for WebKit and Web Engine in 5.5 probably, but so far this is what you will get with 5.4. So I mentioned before that you need some kind of IPC channel, so a transport mechanism which delegates the messages or, for example, the signals emitted on the C++ side to all JavaScript clients you have. And vice versa, you need to talk back from the JavaScript clients when you invoke a method or something like that and send that to your C++ code, right? This is done via objects that implement this so-called QWebChannel abstract transport class. It's trivial. It has just two functions: send a message and receive a message. So far, there are 3 existing implementations: the QWebKit 2 IPC, which is very efficient, similar to the Qt Web Engine IPC. Both of them you cannot access from the outside. You just use the web channel that is created by the web views, and it makes it highly efficient, and you don't need to do any custom setup code there whatsoever. If you want to use Qt WebSockets, that's also possible. The Qt WebChannel examples include a code that show how to use WebSockets here. And that actually brought us to some very nice side effects. I mentioned that Norm initially used WebSockets because it was easier to do than writing the C++ code in WebKit or Web Engine to actually reuse the native IPC channel there. But in doing so, we realized that once you use WebSockets for communication purposes, you can talk to anyone that supports WebSockets. Similar to what was mentioned in the talk before with Qt.io, you can now run applications in a desktop browser or in a mobile browser, maybe wrapped via the Qt Web View things, so iOS browsers, Android browsers. You could use Node.js server applications or Qt Quicks 2 standalone applications that maybe run on a completely different machine. And as soon as you connect them via WebSockets and connect those then in turn to the web channel, you can transparently access the same Qt objects from everywhere. Here I show how it's done in a bit simplified version in the Qt Web Channel examples on the C++ side. I create a WebSocket server. It's a Qt module since 5.3, I think. Listen to a local host address with a specified port that I can then use later. And the WebSockets don't support or don't implement the transport interface I use internally, right? So what I need to do is I need to wrap incoming WebSocket connections in these objects that implement my QWebChannel abstract transport class. So this is what this wrapper is doing. And now I can construct my channel. I can publish as many objects as I want to. And then when a WebSocket comes in and connects to our wrapper, we can then connect that one to the web channel, and everything starts working. On the JavaScript side, I again create the WebSocket. You could also use the secure scheme here as long as you have everything set up there. There's nothing that prevents that. And then once the socket gets opened, you have the raw IPC channel running. You set up the web channel to get the nice to use API, so no manual message came in. It's a method called do something. So, but all the web channel magic, it's essentially just what we had before in a simplified form. This time you pass the socket and not the navigator.QtWebKit transport. And then it works. So let me show you. Oops. This is a raw C++ with Qt widgets application. It runs the web channel, and this now, well, let me show you more explicitly. In the background is HTML running inside my Chromium desktop browser, which connected to the C++ application via WebSockets. So not sure whether you can read that. Oh no, it's not here, but I passed the port and everything somehow to my client, so I know the what server I need to connect to. I do what I showed on the previous slides, and then I can again chat between these two clients. Oops, right. So, message received. So that works. But not only that, I mentioned before that you can also have multiple clients running. And I mentioned that you can do the same with Node.js. So let's run a Node.js example. This was provided by our friends from Basiscom, and they made it work so that you can trivially import the QtWebChannel.js in Node.js, and then you can just chat again with our C++ demo in the background. So let me resize that a bit. Wait. So you see that works. And let's do something else. There's a oops. I actually have slides for that first. There is a way to get the same thing running in raw QML. So assume a tablet or something running just the QML application, and you want to talk to some C++ or other QML application running potentially on a server or some different machine. You could use the WebSockets there as well. You will need some glue code here to actually make the cute WebSockets that you can use in QML more in sync with what the HTML5 API does for WebSockets. It's a bit unfortunate, but it's not that much work. You essentially just need to add this send method and a property which essentially you forward to the on-text message received signal. That's about it. Once you do that, you can then create your web channel when the socket is opened, so connected to your server, just what we did in the embedded WebView clients as well. And you call your callback and then start using your objects as you would know. Here I just include the resource, the QWebChannel.js API as a resource file. So let me show you that this works as well. C++ server, which we used before, and the QML client. So here's our C++ server still running. And here it is. You already saw that it connected, and as before, remember that this could work on any machine. And if you're interested in how to do that, you could also take a look at the Basiscom booth. They have a full demo running there with multiple clients connected, and they all make use of the web channel to achieve this goal. So let's get back. I want to give you some tips and tricks, lessons learned in the product we developed for a customer of ours, where we, as I said, heavily rely on QWebChannel. It's running on a, well, not so powerful embedded board, and we learned there that you need to be very careful because differently to the, or in contrast to the old QtWebKit bridge, what you do here is you actually serialize data and send it over, so you copy data. And you need to ensure that you, well, if performance starts to slow down, minimize the IPC traffic. So what does this mean? You need to ensure that you don't emit signals every few milliseconds because some sensor changed, for example, rather maybe just do it once a second or something like that, right? That was actually one of the cases. It triggered to, well, it led to a lot of power consumption on the device, and because it only had a single core, you also noticed that a lot, because whenever you send the IPC message from your QML message to the HTML process, the context will be switched from the CPU, and then everything else gets blocked essentially again. So take care about that. There is a possibility that if you have multiple web views running, that you share them or share their web channels. So what that brings you is that you can save the serialization step and only do it once instead of once for every web view you have. Depends on whether you do that. Our customer did that for running multiple apps in a sandboxed way. And if you then, for example, hide the web view, there is a property on the web channel which you can tell, okay, please don't do anything anymore. That's very helpful, again, to then not send anything. And once the web view becomes visible again, you can unblock the updates and everything gets sent in one go, and you didn't waste any CPU cycles and power while nothing actually could ever be visible to the user. So far, I showed you that you can, well, you plug in your object and it gets its signals, properties, everything available to all JavaScript clients. And especially once you use WebSockets, you need to be sure that these methods you publish there are actually safe to access, right? So my suggestion here is to write essentially dedicated QObjects with a slim minimal API that only have the signals and methods you deem safe to be used from the outside. And as I said initially, do keep the memory overhead in mind. Our customer wanted to plot data on the HTML client side with a JavaScript library. And what they did initially was they sent over, I don't know how many thousand data points from the C++ QML side to the HTML client. So you copied all the data, you serialized that, sent it over, which was quite slow in the first place because it was a huge amount of data. Then you deserialized that, which takes a bit of time in JavaScript. And then they filtered the data and actually created 400 points because the screen was only 400 pixels wide, right? So instead of filtering on the C++ side and only sending over 400 points you actually need, they did it all on the HTML side. That was very slow, led to a huge amount of memory overhead, and we had to make sure that this was done differently in the end. If you have any questions for that, you can always ask us, of course. So to wrap up, the QtWebChannel is already somewhat easy to use. I completely agree that it's not as easy and trivial to use as the QtWebKit 1 bridge. I do have plans to make it easier, but there will always be some more complication due to the asynchronous nature of the whole thing. But in turn, it turned out to be much more versatile. It not only solved the initial problem of getting the interaction running between HTML JavaScript clients running in QtWebKit 2. It also was very trivial to adapt that to Qt Web Engine. Pierre here in front has a patch for that on Garrett, and I think it should be in 5.5. We sadly missed the feature freeze for 5.4, but yeah, that's life. There is a overhead due to serialization you should not ignore. And in general, I would say if you start using HTML on embedded boards, be warned, there will be more issues than that. So the outlook, to wrap up my talk, is, as I said, Qt Web Engine integration, but also trying to simplify the whole usage there to not require you to manually set up the QtWebChannel at all anymore. I said it's possible in theory via using WebSockets to also talk to the HTML clients running in Qt Web Views, so on Android and iOS. I want to make sure for 5.5 that it's as simple as with QtWebKit and QtWeb Engine. And Basiscom is working on improved multi-client support and some more things that I personally did not have in mind at all initially, but it turned out it works very nicely, and yeah, I expect many more patches from them. And something as a research project I would like to do is add more language bindings. Right now it's all done in JavaScript, but there's actually nothing which prevents us to implement the API in Python or Ruby or whatever you want to use, and then create dynamic objects there which you could use just as, well, any other object in the language you pick, and then you suddenly can add scripting support in Python to your application, or yeah, whatever else you have in mind with that. It should be doable with the approach we took here. So yes, with that I come to the end. Do you have any questions?
So, questions, we will start here.
Hi, you mentioned that there are different transport channels for QtWebChannel. Can you repeat, please, the difference between them? Because I didn't got it really. Yeah, thanks.
So far, there are 3 existing ones, and in practice, you should never care about that unless you want to do something special. So what these are about is just a way to communicate with the HTML clients, so maybe a different process, right? And for example, QtWebKit, QtWebKit 2 that is, with its multiprocess architecture already requires some kind of IPC mechanism. So for example, if you click somewhere, it needs to transform that click event into some message which then gets sent to the other process. We reuse that for the web channel integration in QtWebKit because the IPC channel is already there. There's no need to create a WebSocket or whatever, right? So that's what we picked there. Similar for QtWeb Engine. Again, there is an existing IPC channel. We just use that. For everything else, we picked WebSockets. But if you have your own idea, maybe a raw socket or anything else with which you can communicate with some other side, you could just implement this transport mechanism and then make it run however you want to. So that's the gist of it. Did that answer your question? Okay, cool.
So who's next? So is it now possible to run a multi-threading from on the C++ side from JavaScript, start many workers?
If you have multiple JavaScript workers running?
No, if I have the JavaScript and I want to start multiple C++ workers. Because that was not possible before, because it was synchronous, so they started one after the other. Are there any gotchas?
In principle, no, because Qt's signal slot mechanism is already thread safe. So essentially what you can think about is that signal emission, it just works, and the method call is essentially the same as you would use Q invoke method, Q meta object invoke method with a Qt connection. So that's thread safe as well. So in theory, there should be no issue with that. I didn't try it out, but I think you should try it out. It should work. And if not, please tell me and I'll make sure it works.
First, one question here.
Thank you. I saw that in your examples you are using only text messages. Is it also possible to transmit binary messages like images or whatever?
Yes, the examples I picked are very, very simple. I thought about that later as well. If you would just use WebSockets, this would still be very simple. I should start or create a better example for that probably. But yes, binary data is possible to send if you first convert it to base 64. That's what the guys at Basiscom do, if I'm not mistaken. but I do plan to make this more easy as well. So this is done on the fly for you transparently, so you don't have to care about that. There's nothing which prevents that. It's doable.
So, a question in the front.
So I have a couple of questions. The first is about the level of interoperability. So can you also create objects in the JavaScript side, or if you use it, if you connect from a QML client, can you also, for example, connect or create bindings to these objects that you get remotely?
No, you cannot. Well, yes and no. Yes, you can create objects on the JavaScript side as long as you have a factory method on the C++ or QML side, right? If you would just instantiate my QObject class that I have in the QWebChannel.js file, no one will know about that, so that won't give you anything. But there is support that if a method call or maybe a signal argument contains a QObject star, this one in turn gets wrapped as well and serialized and then accessible to this client. And yeah, that should work. If you then want to use that object in a QML binding, well, you would need to have the object in the first place, right? So that's not really feasible. It's a clash between a procedural way of programming and a declarative way. And yeah, since JavaScript is inherently procedural, it does not make much sense there.
My second question will be, you mentioned that it's possible to use this in iOS thanks to the WebSockets. Are there any limitations about how can you create a server for listening?
To my knowledge, no. I hope that Apple did not restrict the construction of a WebSocket server. I may be mistaken. I didn't try it out yet. I assume that it should work. And probably there are existing applications which do something like that, like create a WebSocket server and then you can talk to maybe your watch or whatever. So I do hope that Apple allows that kind of usage scenario.
More questions? Over there.
Could it be ensured that with WebKit 2
sorry, could you...
sorry. Is it ensured that with the WebKit 2 the object which are registered in JavaScript will be available on the load?
On reload, you mean?
On load, on body load. I mean, with the WebKit, we received the notification when the JavaScript object could be registered. Yes. So we registered the object, and they're available whenever client wants in HTML.
Right.
With HTML, with the WebKit 2, it is due to asynchronous. The JavaScript engine continues to run, and when were they available?
When this function gets called, you instantiate your QWebChannel and you pass it a callback. And as soon as that callback gets called, you have access to channel.objects, which is an object map, and then you can access anything in there. But before this gets called, you don't have any access to it. Channel.objects will just be empty.
Thank you again for the wonderful presentation.
Thanks.